All right, Richard, you can go ahead.
Hi, everyone. My name is Richard Weiss. I'm president of the Explorers Club. I hope you're well wherever you are in the world. It's been such a wonderful tradition, all these Zoom Monday night lectures. I'm always pleased to see that we have people literally from 7 continents, and maybe after tonight's lecture, we'll go a lot further. But what the reason why I'm really here is to announce some great news. About a week and a half ago, the board of directors elected a new president. And the name of that president is Richard Garriott, a good friend and colleague of mine. And he will take office on April 10th. And Richard, I guess you don't have to be a rocket scientist to be president. Oh, wait, you might actually be that. So I wanted to wish you a congratulations and all the best. You've been such a terrific guy to work with during the 3 years I've been president. I just think the club is lucky to have somebody of your caliber.
Well, thank you, Richard, very much. I greatly appreciate that. Appreciate the introduction. And more than anything, I appreciate the great education that I've gotten working with you over these last few years. We've got some great work done these last few years, and I hope to build upon that for the next administration.
Well, I look forward to hearing tonight's lecture, as I love hearing you interview people. And Alan Stern is by far one of my top 5 lecturers out there. He is cream of the crop. So I'm going to sit back and enjoy this. And everybody, you're in for a treat tonight.
Great. Well, thank you again, Richard. And good evening, everyone. Welcome to the Explorers Club Monday night lecture series. I'm Richard Garriott, as you heard, your host for the evening and recent president-elect of the Explorers Club. Tonight, we have an incredible treat, speaking with one of my favorite people in the exploration world, Alan Stern. The theme of our chat, as you all have already read, is a Virgin Voyage into space exploration. Tonight, we're going to be really more than a lecture presentation. We're going to be having a discussion not only about Alan's earlier work prior to the New Horizons mission, but obviously that's one of the biggest things to have happened in anybody's lives for the last decade or so. So we'll be spending a little bit of time on New Horizons. Of course, the focus will then move to his upcoming Virgin Galactic flight, some of his the new missions he's getting ready to undertake as well. And I even have some questions that we'll be discussing about the future of space exploration broadly. And while I have some of my own questions, and Alan, actually, I understand may even have a couple for me through that, we're going to be gathering questions from the Facebook feed. So if you have questions of your own, the team back at the club will be gathering those and texting those over to me so I can insert them into our discussion. For those of you who don't know Alan, let me give a little bit of a brief introduction. Alan would describe himself, I think, as a planetary scientist. He was former head of all NASA science missions. He's an author and speaker and a co-founder of Worldview. In 2020, NASA appointed him to fly as a crew member aboard a Virgin Galactic suborbital space mission that is expected to fly in 2022. He's been for 29 years at NASA and ESA on their space missions teams, 14 of those times as a principal investigator, including, of course, the big recent one, the $1 billion New Horizons mission that was the first mission ever to explore Pluto and is now on in exploring the Kuiper Belt. And so that's been the New Horizons has conducted the farthest explorations in history. Dr. Stern is a member of the U.S. National Science Board. He's a former chairman of the Commercial Spaceflight Federation, has published over 330 peer-reviewed scientific papers and 4 books. I think one has recently coming out. He's an instrument-rated commercial pilot and flight instructor. He's done scientific research at the South Pole and the Arctic Circle, and has also certified or flown in a variety of high-performance aircraft. He's a fellow at the American Association of the Advancement of Science, the Royal Astronomical Society, and importantly for us, he is one of our fellow members here at the Explorers Club. And in fact, he's not only received, was it the Sweeney Medal, Alan? Am I getting that wrong? Is it the Sweeney Medal you received?
No, it was a different one.
Which one?
Lowell Thomas.
Lowell Thomas, there you go, thank you. And in 2007 and 2016, he was named to the Time 100. So again, what a treat, Alan, to have you. Welcome. thank you for joining us, and we'll get into discussion here momentarily. But thanks.
Thank you, Richard. Thanks for that wonderful introduction, and congratulations on the honor of taking the reins shortly for the Explorers Club. Fantastic.
Well, thank you. And you were kind enough to send in some images that we could play with this evening. And so I'm going to screen share here and show folks the first of these images.
Again, with like handcuffs. I had to send pictures.
Exactly. And you were lucky enough that one of your parents was, or friend was smart enough to snap some of these early pictures to show you getting into science at a young age. Can you describe this kind of boyhood influence and kind of where your path to science started?
Yeah, that was a picture in our den in New Orleans, Louisiana, where I was a boy, taken by either my mom or my dad at the holidays. I think the year that I was going kindergarten or first grade, and it was my first scientific instrument. It's the only one I ever worked with that looks down instead of up. But it was a wonderful experience, just getting to know a little bit about optics, and better than that, to look at all these bugs under the microscope and everything else.
Yeah, fantastic. And in your early career, you've had such a long career in science now, and in particular in space exploration. You've been involved in, or been the principal investigator on, things like Spartan, an astronomical satellite, Rosetta, a comet orbiter. I actually have some meteorites that Rosetta helped identify where they originated from, that I have in my own collection. So I have a personal collection of that one. The New Millennium Deep Space One, Mars Express, Hubble, Suisse that was looking Suisse was looking for the Vulcanoid asteroids between Mercury and the Sun. Really some great. Any one of those would be great. But in the interest of time, tell us which one of those is your favorite, or give us a standout moment from those earlier missions that you think is worth bringing back up.
Well, I thought about that question a little bit after you sent it over this morning as a possible question, and I decided that the question is a little bit like Sophie's Choice. For a scientist, all of the missions have been favorites, because they're all very different. Rosetta was this opportunity for a small number of Americans to participate in an enormous flagship mission of the European Space Agency, and I was fortunate to PI one of the 3 U.S. instruments on it. The first mission to really stay with a comet, not just fly by it and see it in a flash of time, but watch it evolve over years as it went around its orbit. Tremendous scientific outcome. And understanding these time capsules from the formation of our solar system. And Swiss and Spartan Halley were opportunities to be involved in the space shuttle program with Halley's Comet, and then later with a whole bunch of different planetary astronomy, like the Vulcanoids that you described. And every other mission that I think back that I've been involved in, from suborbital rockets out of Poker Flat, Alaska, up near the Arctic Circle, to other shuttle missions and on to planetary missions. I've loved every one of them. I can't say that, except for New Horizons, which stands head and shoulders above the rest, they are all very close to my heart, and they've all been a privilege to be a part of.
Well, when you think about, or at least when I think about New Horizons, it's clearly going to go down in history as one of the great human endeavors into the cosmos. I mean, as Voyager, may have done in our childhood.
It's Voyager for our generation.
Yeah, exactly. And for people who don't understand the magnitude of these particular endeavors, their timelines to me often elucidate some about their greatness or bigness at the very least. It was launched in 2006, made it to Pluto in 2015, made it to Arrokoth, which I'm probably mispronouncing, which should still be called Ultima Thule, in 2019. It's the 5th item to reach, 5th vehicle we sent out that has reached escape velocity of the solar system. But I know if we wind that back to 2006, that's not when the thing actually started. It actually started a long time before that. So can you take us back to it's still going on now. When did it really start?
Yeah, well, you're right. Absolutely right. To get to the launch pad, it started with a group of people, young scientists in 1989, when Voyager was finishing its planetary exploration by exploring Neptune, the last of the giant planets, and not going to Pluto, who kind of looked around and said, why isn't NASA doing that? Isn't there some unfinished business? And we worked on that pretty hard. We got NASA to do a study, first one study, then another, and then there were problems, and then there were successes and reversals, but the whole thing took 17 years to get to the launch pad. Along the way, NASA tried 6 different times to do missions to Pluto, and finally threw up its hands in 2000, and said we quit. And there was such a public and scientific outcry that NASA cried uncle and said, all right, we'll try one more time, and this time we're going to call for proposals instead of doing it ourselves. And fortunately, at least for us, the team New Horizons, which I lead, won that proposal competition in 2001, and then spent 52 weeks a year and 7 days a week working at breakneck pace to build it between 01 and 06 when we launched it. That's about half the time it took to build Voyager, design and build Voyager, to give you a scale. And then, as you said, we launched in 2006, took 9.5 years as the fastest spacecraft ever launched to cross the enormous ocean of space in our solar system to reach Pluto, farther than Neptune, which Voyager took 12 years to reach after 9.5 years, and conducted a flawless flyby, followed by the retargeting for Arrokoth, and that flyby in 2019. And the spacecraft continues on. I like to point out 2 things to illustrate the scale and some of the magic of New Horizons. One is that these are big projects. They're really big teams between the launch vehicle, the spacecraft, the payload, the ground team, the science team, the nuclear power generator. 2,500 men and women work to mount that expedition and fly it. And then the other thing that's special to me is that, like the Voyagers, because New Horizons is leading our solar system for interstellar space, Carl Sagan used to say that the spacecraft we send out to the solar system will potentially outlive our civilization. For those that are gone, leaving the solar system altogether, they will literally outlive the Earth. When the sun becomes a red giant and engulfs the Earth, and there is no more Earth, those emissaries of the 20th and 21st century will be out there in interstellar space, more or less perfectly preserved. And I remember being with our spacecraft a few weeks before we shipped it to the Cape one night late in the clean room, and just thinking about that and how incredible it was that we had built something that, if it all worked, would outlive our planet.
And I agree that is it's both profoundly positive in the sense of we've sent this message out there, but it's also really does make you think about the mortality of our planet, in an interesting way, to just go, it makes a pretty good case for, we need to find escape. We need to figure out a way to get escape velocity for the rest of us at some point. We fortunately have a few billion years to figure it out, but ultimately we're going to need it.
Well, Elon is right that we need to be a multi-planet species. He's not the first to say it, but he's got the bug, and he is helping to make it happen.
When I think about a vehicle that's traveling this far out and will presumably, there's part of the question is, how long will this continue to operate? So, Voyager is still operating. It's, on a pretty low power mode at this point. What about New Horizons in the sense of it? I presume you must put it into something like a hibernation mode for fairly long spans of time, and then wake it up to see where it is and make sure it's on target, I would guess. Is that a close description, and what is it like?
We used to hibernate that spacecraft a lot on the way across the solar system, but we don't any longer. We could, but we just don't operate it that way. The primary consumables on board are first the power, because we're so far from the sun you can't use solar rays. We have a nuclear powered battery, just like the Voyagers and just like the Pioneers before them. And we estimate that we can probably run the spacecraft on that another 15 to 20 years. But every year, as that half-life takes effect, there's just less and less wattage coming out of the power.
I presume there's no way to store it, so you might as well leave it on and using it. Because...
Right. And even if we carried a battery, it would only be good for a day or two.
Right.
So it wouldn't substantially lengthen the mission. But our engineers are very clever, and they keep figuring out new ways to operate on less and less power. So we have models that show we can operate it into the 2030s. The other big consumable is fuel. We're down to about 1/8 of a tank. We can husband that fuel and operate into the 2030s, but we have to be very careful with its usage. We use it to point the spacecraft, to do observations, and to conduct flybys. And I have dubbed myself the New Horizons fuel hoarder in chief.
Yeah, I like the hoarder in chief.
The fuel that goes out of those thrusters has to pass my signature.
And I presume also that's why, down through the years, you know that almost every time we've had a chance to speak over the last few years, I always ask you, what's the next target? And I presume the trick of another target is you got to find one that is, you're already traveling really fast in one direction. And so any flyby has to be pretty darn close to that vector to be worth it for the fuel.
And it's a needle in a haystack problem. In part, for those of the people that are on the line who are amateur astronomers or for that matter, professional astronomers, our direction of flight, which was aimed in order to cross Pluto's path at just the time that it crossed the plane of the solar system, is toward the galactic center, the constellation Sagittarius. These are the densest star fields anywhere in the sky. And so we're looking for faint embers within our fuel reach against this blaze of background stars. And it took the largest telescopes on Earth and the Hubble, a combination together. It took 4 years to find Arrokoth. We are now 1 year into the search for the post-Arrokoth flyby target. Haven't found it yet. The odds are against us because we don't have as much fuel as we had before. But the technology has moved along. We're now using machine learning techniques to analyze the data that we have proven already can do better than us humans. And since I'm an optimist, I'm hoping that we get another flyby out of the spacecraft. Even if we don't, we operate it as an observatory in the Kuiper Belt, doing all kinds of cool science, important science, and not just for planetary, but also we have done important heliophysics and now some important astrophysics. And since this is the only spacecraft in the Kuiper Belt, and the only one planned to go that way, at least for a couple decades, it really is a resource, and we plan to milk it to learn everything we can about that environment, that place, the origin of the Kuiper Belt objects, and just maybe get another flyby out of it too.
Yeah, and I hope, my fingers are crossed, I hope we do too. I was going to save a lot of the questions for at the end of our main stream, but this one's contextual to where we are and is right in line with what my own question was coming up too. So I'm going to pop this one in here. Brian Hansen from our Texas chapter jumped in and he said, were you upset when Pluto got kicked out of planetdom?
I was disappointed. And in fact, I think most planetary scientists feel the same way, because the astronomers, which is a different field, a neighboring field, they really made a tragic mistake. They really, I think, damaged science in not recognizing the dwarf planets as planets, because they had to share every attribute of planethood that planets have that matters. They have atmospheres and moons and mountain ranges and oceans on their inside, and they're the big and round objects that you would spend years on a trek, trying to travel around. And on any Star Trek episode, if they showed up on the viewfinder, you'd call them a planet. And yet the astronomers, surprisingly, were afraid of astronomically large numbers of planets. And the school kids couldn't remember all those names. So they just figured out a way to legislate to have small numbers of planets. I think that's pretty anti-scientific.
Yeah, and I'm with you. I have a quote here in my personal cue cards here that said apparently you said the New Horizons Project ... will not recognize the IAU's Planet Definition Resolution of August 24th, 2006. Is that an accurate quote?
It is. And I'll tell you something very interesting on that. A brilliant planetary scientist named Phil Metzger down in Florida recently took a look at the scientific literature, looked at thousands of articles about our solar system in technical journals written by professionals, planetary scientists, since 2006. You can't find one paper by any author or group of authors that uses the IAU definition, except papers explaining the IAU definition. It's completely irrelevant. No one uses it.
That's hilarious.
But we're vindicated.
Indeed, indeed. And I'm with you to be sure. And another person, Liz Spiteri, actually asked another one that is akin to where I think we are in our flow, which has to do with the where is it now and what's the velocity now? And I'm going to add another one in there. And how does that compare? Because I asked you a couple of days ago in advance as we were queuing this up about how is it traveling in contrast to those other 4 vehicles that also have reached escape velocity. So how is it doing compared to those, and where is it compared to those?
Right. And here's a tidbit for Explorers Club listeners. There are actually 10 vehicles, not 5, because each of the other 4 and New Horizons also has an upper stage, a derelict rocket following the same trajectory.
That's traveling fast enough to be in escape velocity.
Yes. That's right.
And so if you think if all 5 of them have that, then the ones that surely the ones then that launched the Voyagers as a case study are they out beyond Pluto already, or are they?
Yeah, they're very far beyond Pluto. That's right.
Wow. And are they being tracked? So they're on some database.
Not being tracked. They're derelict, so we can't see them. The Voyagers are still in contact, but the upper stages, they died within 24 hours of launch because they're just battery.
But radar, we're not tracking them. They're so far away, we literally have no way to track
for radar. Yeah.
Wow.
Yeah, but they're out there. And so our spacecraft is traveling at a speed of about 14 kilometers per second. I'll put another way, that's San Francisco to New York in about 4 minutes, 24/7. Or put another way, it's about twice the speed of the International Space Station that you flew on. And we're coasting. We're just, from the power of the initial launch, that ferocious rocket in the upper stage, and then one Jupiter gravity assist, everything else is coasting. And we only use our engines to make little retargeting maneuvers.
You mentioned only about twice as fast as the ISS, which is also pretty close to escape velocity of the Earth. So is escape velocity of the Earth and escape velocity of the solar system, comparable, or are they?
No, it's just that in the same way that on Soyuz you had to climb uphill against gravity, we've had to climb uphill for over 5 billion miles to get to where we are against the sun's gravity, and it's slowed us down
okay.
Our maximum speed.
So its current speed is twice that, but it has actually been at a much higher velocity.
About triple that speed.
Okay, that makes sense.
I mean, to give you an example of the speed, the old Apollo missions would launch at 25,000 miles an hour and reach the moon 250,000 miles away 3 days later. New Horizons crossed the orbit of the moon 9 hours after launch.
Yeah.
Like 0.3 days. So very fast.
Very, very fast.
Not fast anymore. Now the Voyagers started off slower than us, but they had more powerful gravity assists from the giant planets. So both Voyagers are actually traveling a little faster than us, 10% faster. And so we'll never catch them. We're overtaking the 2 Pioneers, Pioneer 10 and 11, but we will never catch the Voyagers.
Yeah.
And hail to Voyager, what a mission that was.
And Brian Hansen had another question too that I thought I'd stick in here before we move on, which was, how did Ultima Thule, or however the new name of it,
Arrokoth.
How did this shape happen?
How did this shape happen? That's a really profound question. It is a really unusual shape, and unfortunately, this is a 2D image which you can't tell from this image, but you can Google it on the web and see animations as the spacecraft flew by. We saw it from different angles. It's actually both lobes of that so-called contact binary, a pair of objects that are touching at that bright seam called the neck. But both lobes are flattened. They look like rocks you would skip along a lake, except they're big. The length from stem to stern of Arrokoth is about 20 miles. It's about 36 kilometers. So this is a large thing. It's like the size of a major metropolitan area. And the 2 lobes we have learned from New Horizons data, formed close to one another in the solar system, intimately close, and were originally in orbit around one another. And as that orbit decayed, they came to very gently merge. We actually, in the first scientific paper, which was published in Science, with myself as the first author in 2019, Richard, we said that the two lobes eventually lost enough angular momentum and docked.
Yeah.
And the editor of the journal Science said, you need to find another word because that suggests that it was piloted to a docking. So we use the word merged. But and we can see from the geology and many other telltales that the two objects came together at about the speed of bumper cars. And they have just enough gravity to overcome that and not bump away like bumper cars, but to then merge together into that bilobate object.
Yeah.
Contact plane.
And a couple of folks have asked questions along this line about, and I'll give credit here to Mark Brian Brown, about if you're still processing data, and what is the data rate that you're getting back from the vehicle?
Yeah, great questions. So we're not only processing data, we're still getting data every day, or virtually every day. The spacecraft sends more data back to the Earth from new observations we're making, and still some data that we have not yet shipped to the Earth because of higher priorities. It's from that flyby in 2019. Now, we don't have a very high data rate. And here's why. First of all, we're 5 billion miles away. The antenna is not much larger than this, than the span I can reach. And the transmitter, it's not like an AM radio station with 30 kilowatts, it's 30 watts. So we got 30 watts from 5 billion miles away through a small antenna that doesn't focus as well as a giant antenna. And as a result, our best data rates now through NASA's giant tracking antennas is a little north of 1,000 bits per second. You would not read your email at that speed. It would be too frustrating. It's 80s modem speed. But by
the way, 80s modem speed, I wrote a lot of games in 80s modem speed. So you can still get a lot of work done at that data rate, especially if you can track it for most of the hours of a day. I don't know if you have 24-hour data capability.
We share the Deep Space Network with a lot of other missions like Voyager. And actually, the Voyagers are in the same direction as us, so they have to use the same antennas. So we split the time among all these deep space missions. We don't get 24/7 except for critical support like flybys. And the Voyagers are further away, and their data rates are down around 100 bits per second.
Yeah. Well, I want one more question about New Horizons, then I'm going to move on to a little bit into the future, which is some folks have been asking here. Jenny Welko-Wiki, sorry, Jenny, has asking about gravity assist. So some folks really don't understand how does that work? And I'm at least somewhat familiar with it, but a lot of folks I presume are not.
Right. This was gravity assists work using very basic orbital mechanics. It was figured out in the mid-20th century and first pioneered by the United States in the very earliest days of planetary exploration with the old Mariner series. And essentially, when a natural or a human-made object goes by something big, the two exchange angular momentum. And if you have the right aim and the right trajectory design, your spacecraft can get a boost in speed as a result of that at the expense of the planet it flies by. But it only, the ratio of the mass of the spacecraft to the planet is so astronomical that the planet hardly feels the difference. And yet the spacecraft can get a big boost. In our case, we didn't have to fly very close to Jupiter for our gravity assist. We got a 5,000 mile per hour boost for free or at Jupiter's expense. Some spacecraft have flown much closer to Jupiter to get bigger boosts and have picked up literally more than 10,000 miles an hour.
Yeah, so and I presume, of course, that trade took a little bit of inertia out of Jupiter, but obviously inconsequential.
Right, and it's the same orbital mechanics that let the old Apollo missions be on what was called a free return trajectory, where they could aim for the moon, and if their engines failed to work to break them into orbit, they could loop right back to the Earth. It's all the same orbital mechanics.
That's great. And I said that was our last New Horizons one, but I forgot one I wanted to ask, which was to talk about the gold records on Voyager. When I see those records, even as a kid, when I saw them, I went, part of it is brilliant, you know, because tell you about where it came from and it's a little bit of science and things. And then part of it, I was going like, why did we say hello in all the languages on Earth? Because there's no information in that. And all it will be is incredibly confusing to the recipient without really imparting any knowledge to the recipient other than maybe we're culturally or linguistically diverse, maybe if they figured it out. But did New Horizons do that? Do you have any, you know, what is its, since it's one of our emissaries that survives the Earth, what are people going to think when they find it?
Right. Well, I like to think that the old Pioneer plaque and the Voyager record were as much messages to ourselves as a reflection of that era, you know, the 70s and the 80s, as they were messages to any civilization that might somehow find the needle in the haystack out there. On New Horizons, we chose not to do something like that, but instead to fly some memorabilia. We flew 9 different kinds of memorabilia. Probably the best well-known is that we flew some of the remains, the ashes, of Clyde Tombaugh, the discoverer of Pluto, who had made that request. If a mission ever went to Pluto, he would like to see his ashes aboard the spacecraft, and we did that. And he is now the first human being launched into interstellar space, at least
Excellent.
in the remains. So we did not put a message aboard. I'm fascinated by the idea, though, of putting a message up there in the digital memory of the spacecraft someday, later when we don't need the big memory banks for flybys. So that's something we might talk to NASA about doing. We'll see.
Excellent. Well, let's move on. Let's move from New Horizons. I've got more questions, people. I've been getting your queued. I've got these queued up. So if we get a chance at the end, we'll come back and ask some more New Horizons questions. But let's go on to the future. Let's jump in with the big news in your not too distant future, Virgin Galactic. And so you have recently been selected by NASA to be the official scientific astronaut on a 2022 Virgin Galactic scientific mission. First, I'll see, how did this come up? How did you get picked? What do you plan to do?
That's a lot of questions, Richard.
Yeah, well, you're up for it.
It's a test.
It's a test.
Yeah. So I've had a long-term interest in spaceflight, and hadn't been successful in achieving that goal. But have been very heavily involved, as you know, in the commercial spaceflight industry. And I was early in advocating that we press these tourist vehicles into the service of science, because when you work up the numbers, they have the potential to do a lot more science than the suborbital sounding rockets that we fly in the NASA program, and do it at a lower cost. So that's a tremendous value proposition. Do more for less. And who wouldn't take that deal? And in fact, I've also been a big advocate that a lot of how we do space science, you know, I've been on 29 missions. You said that. I've been a principal investigator on 14. I've never been into space, because when the space program got started, we just didn't have the ability to send people into space on a routine basis. It was extremely selective. It's the only field of science where we don't send the scientists on the scene. Volcanologists go to volcanoes when they're erupting. Polar scientists go down to the South Pole or the North Pole.
And we sent exactly one geologist to the moon.
Exactly. Very special situation. But that's about to change in the 21st century. And NASA has recognized that. And last year, NASA offered the opportunity for scientists to write proposals, scientists and technologists, I should say, to a particular announcement of proposal opportunity to fly on these new generation suborbital vehicles. And my team at the Southwest Research Institute, that had already built instrumentation and that had already contracted for 3 flights as a private company doing business-to-business transactions with Virgin Galactic, had bought 3 flights for myself and Drs. Kathy Olkin and Dan Durden to fly as researchers. NASA bought one. Our proposal was successful. In fact, just to tell a funny story and to name a friend, when I got the announcement from NASA in early October that I've been selected, they said, and we want to announce it publicly. And so they said, you probably want to write a press release. We're going to do something. We're going to announce it, and we'll coordinate them. And so we started on that. And then after 4 or 5 days, just a couple days before the announcement, I said, well, okay, we would like to know who else has been selected so we can coordinate with them too. And they said, oh, we only selected one. And I was floored. And when I told my friend and colleague Dylan Taylor, who's very well known in commercial space circles, this, he said, imagine, he says, Alan, you're the first scientist NASA's ever selected to fly in a commercial vehicle for a NASA mission. He said, it must have been something to be in the Mercury 7. What if it had been the Mercury 1?
Yeah, exactly. Exactly.
But so NASA will select more people in the coming years to do a lot of this.
So obviously, when we think about getting into space, when you're not going, when you're only going as far as near space, not going to other planets, there's sort of in my mind, two major attributes of being in space. One is the vacuum out the window, and then the second one is the lack of gravity. And of course, the vacuum can be simulated on the Earth. So if all you really need is an experiment that needs a vacuum, you can do it in a vacuum chamber on Earth. So it's
also a pretty good view.
And the view that's nice for you. I'm not sure the satellites care much, but the people do. And but if you're doing some experiments, then it's really the microgravity aspects that you'll have that are going to be the key thing. So I presume the proposal of the science you're doing is related to microgravity or things that as they arrive in microgravity, like human physiology and microgravity. Can you tell us a little bit about the experiment you plan to do on board?
Absolutely. So I'm not a microgravity physicist. I'm a planetary astronomer, planetary scientist. I'm going to be doing 2 experiments, and I'll give you some of the details. What I have done a lot of is use telescopes in my life, and I put telescopes up in space on suborbital vehicles out of White Sands and Poker Flat, Alaska. I've flown telescopes on the space shuttle, and I'm taking one of my old shuttle experiments that flew twice and bringing it along to look out the windows to see how good Spaceship Two does compared to the space shuttle. So we're testing the efficacy of the vehicle. It's really flight test. And in order to understand how good the vehicle is with all of its real world pointing and the real world glints off that spacecraft, the real world windows, things that you can't model exactly in a computer, not the idealized version, but how does it actually do, looking at different sun angles and so forth with this image intensified camera that flew on the shuttle twice, and which I flew with on many astronomy missions in high performance aircraft like F-18 Hornets and WB-57 Canberras. And then at the same time, I'm going to be wearing a biomedical harness very similar to what shuttle astronauts wore to get a record of my respiration rate, how fast my heart's going pitter-patter, my blood pressure, from the time I put the flight suit on until the time that I take it off, during about a 4-hour period pre-flight, in-flight on the carried portion of the flight, the high Gs, the microgravity, the high Gs on the way back, and then down through landing. To start with just one data set to establish a very large database of human physiological reaction of researchers to this environment to help guide us in the future as to what people should expect and how they can better train for it. That's kind of a passive experiment. I put it on, I turn it on. I've done this, for example, in F-104 Widowmakers, flown those, and it just takes the data in the background. The blood pressure cuff pumps up every couple of minutes, for example. And then you get that data and you download it onto a flash drive when you're done. My real work will be to take Swiss out of its shuttle mid-deck locker equivalent, get it powered up, and then get data from at least 3 different windows during the short space of about 5 minutes of microgravity. So the clock's going to be ticking. And then to get it stowed and then back into my chair and my harness before the onset of what will be 6 Gs on the roller coaster downhill.
Yeah, first of all, that sounds like phenomenal fun, I must say. But also, one of the things that was really driven home to me as a person who flew commercially also was that folks that were selected for NASA by NASA traditionally as astronauts are also amongst the physical elite. And so they are not a good cross-section representation of normal humanity. And because they are so worried about being excluded from future flights and therefore having their career astronaut capability removed, they often don't like to participate in very many medical experiments because that can interfere with their future ability to fly. And so I found that, the six of us who flew on Soyuz commercially, NASA was very interested in our medical data because there's not much around. And so while while putting on a medical harness to test these basic features of what how a human responds, turns out to actually be incredibly valuable data. There just haven't been that many people that have had this test done. And so we need to start tracking that, not just you, but everyone who follows.
I agree. And that's what we basically build this as the beginning of what will become a database of hundreds of flights by at least dozens, maybe hundreds of researchers over time on this vehicle. Is now a good time for me to ask you a question or two?
Sure, yeah, right, go ahead.
All right, so from an experienced space flyer to a newbie, tell me what was the most surprising aspect of doing your work and living in space during your ISS mission?
Well, for me, I was struck by a number of things. Well, first of all, the part you'll enjoy, but in the same way that you've already had a chance to enjoy, is zero-G flights, the parabolic flights that give you 30 seconds of zero-G. A persistent zero-G gives you that same giddy, lighthearted feeling in your stomach that basically never goes away. In fact, it won't. Not only will it not go away in 5 or 6 minutes, it won't go away if you stay up there a year and a half. If you are in space, it is just physically a pleasure, brings a smile to your face just to be in that environment. The next thing I was struck by, which you will also have experienced, is I've also flown high altitude jets prior to my trip to space. And so when I first got to the altitude of orbit, which is 250 miles up, so it's quite high, and the vehicle pitched over to where I got my first view out the window, I actually was struck by how close to the Earth we were. I was actually, in my mind's eye, I expected to be like out at the moon or in deep space or looking back at the Earth from something more distant than the view actually was. And so you're going to find that the view that you see out the window, at least I was struck by how similar it was to high altitude jets. I mean, clearly you're higher, by a modest multiple, but it takes you a minute of looking out the window to sort of take in that, oh yeah, I can see much further around the horizon now that I think about it. And those clouds that in a jet I'd already thought kind of looked like snow on the ground, yeah, they're really much further away. So, but it did take a little while for that to settle in. And then probably the biggest revelation that will take, the trick for you is going to be how to keep some time in your own mind, keep a mental slice of time for taking in the observation versus taking your observations. I used to do some sports photography ringside when I had a friend who was a boxer, and you could either take good photographs or appreciate the match, but it's hard to do both. And that I think is going to be your biggest challenge, which is how to both do your work well, and then how to absorb what a majestic place this is to be, because you really can now see, the impact of humanity all around the Earth below you. You can see the natural processes of the Earth from a vantage point you really haven't been able to observe them from before, and that will be fighting for brain power with the experiment. You really need to finish in those 5 minutes before you have to have it packed away before 6Gs pushes in your lap where you can't get it out.
Yeah, that's great. When you mentioned microgravity, you may not remember this, but it made an impression on me. The one and only time that I brought my wife and 3 kids on a zero-G flight on zero-G Corp in 2010, you just happened to be on board, and we already knew each other.
Right.
Of all people. So
yeah.
What amazing coincidence.
No, well, you'll do this too. Even since my flight, I get on a zero-G flight every chance I can. I mean, being in microgravity is, as you know, a phenomenal experience, whether you get a few seconds of it, a few minutes of it, or, days and days of it. So, in fact, I asked my crewmates when I made it to the space station, I talked to the 2 Russians who I was going to be coming down with. And I said, hey, you've been up here for 6 months. Are you kind of tired of this place, living in the a few school buses, parked end to end. Are you ready to get back home? And they went, well, I've got a wife and kids that are growing up, down there that I probably got to go see pretty soon, or so they don't grow up without me. But if it wasn't for that, I'd stay here. And because it's really being up there, being in microgravity and getting a vantage point of the Earth from very high is really such a profound, experience.
Yeah. Well, I've got another question for you.
Sure.
And you're about the only person I think I could ask this question on planet Earth. And the question is this, because your father, Owen, was a Skylab and shuttle astronaut, who I knew because I served on the NASA Advisory Council with him in the 2000s. I'd like to ask what was the most valuable piece of advice he gave you for your space flight, and what, after your space flight, did you come back and want to tell him that you hadn't anticipated from the experiences he had?
Well, what's interesting is those two answers are related to each other. So what's funny is, for my flight, me and my dad often would do some interviews together, right? Because we were an odd father-son astronaut, pairing. And they would often ask us both, what advice did you give your son, or what advice did your father give you? Mm-hmm. And my father, to the press, would always go, oh, he's well prepared, he's been well trained, he didn't really need any of my advice. And of course, I knew that was inaccurate. But it is, not only he helped me build my entire experiment list, he helped me plan my entire schedule of all my work on the station. He ran the mission control team that actually was my scheduling team. He was with me when I boarded the rocket, and he was with me when I exited the rocket. But what's interesting is that I didn't realize this was the best advice he gave me, but until it happened. But the best advice was that he said, I know you're taking on a heavy workload, which is great to make this time useful, but it's the thing you're going to remember for the rest of your life is the view out the window. And so anytime that you are a daylight pass over land, I'm going to schedule your time at the window doing as little as possible so you can really take in the view. And if it's nighttime or you're flying over the Pacific, the view's pretty redundant. So we'll do the hard work, at that time. And I didn't realize how profound that was. And so there's a term now that is often bantered around called the overview effect that he'd never mentioned. I'd never heard the word till after my flight.
Right.
But the view out the window is so captivating that over time it feels like there's a fire hose of information about the Earth just pouring into your mind as you look out the window. And eventually you kind of reach this moment of literal epiphany where you have a physical reaction where you kind of go like, I now know, in my case, since I was doing orbits, I was going like, I now know the true scale of the Earth by direct observation. And you feel like you understand these other kind of interactions between all the aspects of the natural world and the human impact in that natural world. And to me, I literally felt like being in the movies where in a scary movie where they'll dolly the camera backwards but zoom the lens in, so the actor appears to stay the same size, but the hallway kind of shrinks around them. And so by far, that was the most important and meaningful advice I got from my dad. And then I had to go back to my dad and go, Dad, anytime me or my friends asked you about being in space, you never described that in this many words. He was not a poet. He was not an artist. And that was actually kind of one of his deficiencies, you might say, as a communicator about this experience, but he knew it. And so that advice of, you can't not take in this view, I will make sure you take in this view, because that's the one thing you're going to take with you for the rest of your life, was absolutely it.
That's a fantastic story. What's the other side of that coin?
The other side was that was the best advice, but that was the thing I also wanted to talk to him about. When I came back, since he had never filled in those details, he'd never used the word overview effect. He'd never tried to wax poetically in his whole life. When I would ask him how was being in space or what's it like being in space, it was always, oh, it's nominal. It's kind of like scuba diving. His answers were completely factual, Spock-like. My dad was Spock, as you probably know. My dad's personality was as close to Spock as I think ever existed off the screen of Spock. But hey, can I ask you a question now too? Because I've got a few queuing up here. Sure. And Deanna Weibel Swanson wanted to know about your preparations for your flight. Speaking of, getting physically prepared, or is there anything you're gonna have to do? What's the training regimen like, and in particular, any physical training?
Absolutely. So There are really three kinds of training. And I think the biggest challenge, by the way, is making this work on the first try under a very time compressed environment because these suborbital flights are short. So there's physical training, which consists of flying in centrifuges, which I've done a number of times already and we'll do a lot more of next year. Flying in high performance jets, which is even better. When we fly the Widowmakers, we do 6 Virgin Galactic ascents right off the deck at the Kennedy Space Center, off the shuttle landing facility, and up on afterburner to 30,000 feet at 6 Gs, and then top out with a 0G parabola, back down in the pattern and around again, 6 times in an hour, and that's a workout. And then microgravity flights on 0G corp. In my career so far, I've flown about 1,000 parabolas, not quite, but almost, between NASA old Vomit comets and now those flights. I'm not counting 0G parabolas where you just top out in a high-powered jet and it's 10 seconds, but the 30-second category. So those are the 3 kinds of physical training. And of course, you want to be in pretty good shape, but I don't think you have to be in superhuman shape. I'm certainly not. But then the second kind of training is the actual short compressed course that Virgin Galactic gives you to familiarize you with the vehicle and the whole flight environment. And then finally is the actual operation of the equipment, which I've operated many times on high performance aircraft. But even on those missions, you have a couple hours to make it all work. We took a lot more data, but we're going to be practicing. And in the actual Virgin Galactic spaceship, in a 1G environment, admittedly, but on the ground, because this is a big deal for Virgin too. I'm the first NASA scientist, NASA-funded scientist to go fly. It's in everybody's interest to make sure that this works well. And so we're probably going to practice a lot more than folks down the road, because we want to make sure the first few flights go particularly well.
Yeah, that just pardon me for interjecting a personal story, but on the same 0G plane that we've both flown on, I learned pretty early on doing a variety of experiments, everything for experiments, activities, including I officiated a wedding on a 0G flight. But I did some other work that started on 0G flights and then we took up further. That if we had not rehearsed them if we had not rehearsed them prior to flying them even in 0G, much less when you go to space, there's just no way you could accomplish these things. I mean, when you first do a trial run of a lot of these things, unaware of the fact that you let go of something and it's gone forever, or it's literally a 3-dimensional air hockey table, including for yourself. You want to take a picture with the camera, but if you're not braced, you drift yourself out of scene. And how to even strap your feet down where now you don't go left and right, but you still tip forward and back. And so how am I going to, all these little details that you don't want to hear about, people wanting to go film a feature movie in space, for example, and going like, well, good luck. It's going to be, you better do a lot of ground rehearsal.
Right. So we have a training syllabus. I'm sure we'll refine it. It's about 8 weeks worth of full-time activities, but we'll probably spread it over a period of about 4 to 5 months so that I can carry on the rest of what I'm doing at the same time. And so we're working in very early stage discussions with Virgin to get a heads up for when the flight will occur. And as you know, they're in flight test right now. They haven't opened commercial operations. The first commercial flights will be with some of the earliest people to sign up. We've now been waiting 15 years. And then in terms of the research queue, we're number 1, but it will not be number 1 in terms of what they do. So all that's got to get feathered together, and we'll see how the schedule ultimately works out. But we've told Virgin we want about 6 months heads up on when the flight is to occur, so we can feather in all the training properly without falling all over ourselves at the end to cram it in.
Makes sense. Well, I want to move out to asteroids. Something for me, at least for me, was a real revelation. Somebody put up a really nice animation years ago that I now often use in some of the presentations that I give, that just shows all of the asteroids that are in our, or at least a good percentage of them that are in our solar system, and often layered in by when they were discovered. And obviously we not only have just a phenomenally large number of asteroids, a mind-boggling number of asteroids that we know about, but they're also grouped into some really interesting groups that, at least for me, until this revelation was not known. I mean, I think most people know about the asteroid belt that has quite large bodies in it that have been, that's out there close to Mars. But the Kuiper Belt objects and these Trojans that you're now going to go look for with Lucy are a kind of asteroid of which there are a lot, but have a less obvious orbital mechanic to talk about. So I'm going to bring up the Lucy image, and could you please talk about Trojans, what they are, and why they're interesting ultimately here. But here is the screen to share.
Yes. Okay. So this is the diagram there. There's the Lucy spacecraft at the top. There's the planet Jupiter in the top right. There's a funny looking diagram, which I'll speak to in the lower right, and then some words, which we can just talk about. So Lucy is the first mission to a trapped population of asteroids that are trapped in what are called the Trojan orbital locations, leading and trailing Jupiter, little gravitational pockets on either side of Jupiter that are gravitationally stable. And the interesting thing about these objects are, we believe, from numerical models, that they were formed with many of the Kuiper Belt objects in the middle solar system among the giant planets. They were the building blocks of the giant planets and many of the dwarf planets. And then when the giant planets got large enough to create chaos and clear out that whole zone and throw a lot of things out of the solar system to greater distances or to smaller distances, the Jovian Trojans got deposited where they are. So we think they were born with the Kuiper Belt objects, but had been in a very different location all along. And that by comparing them to Kuiper Belt objects like Arrokoth, we can determine if our whole theory of the understanding of the birth of the middle and outer solar system is correct.
Is it correct to use the term Lagrange point for what they're orbiting? These gravitational
Lagrange points are interchangeable.
Right. Okay.
And so Lucy will visit at least 7 Trojan asteroids. We've never been to one. They are in these 2 pockets. Lucy will go to both pockets. You see the list of the 7 objects there. Some of them even have their own satellites. And it carries spectrometers and imagers to study their geology, their composition, and many more aspects of them, even whether they have atmospheres, for example, and to compare that to the Kuiper Belt objects that are so much further away.
Do we know, for example, these 7, if you know what they are already, that means you're already calculating their orbital periods around their Lagrange points. And so that's a nightmarish amount of mathematics that I see going on there to actually plan in the future something that, I don't know how accurate our forecasts are for the orbits of these objects, but there has to be some error in that, I would imagine, too.
So there is always error, but needless to say, we picked ones with very well-determined orbits. And in fact, the principal investigator of that mission, Al Levison, is actually an orbital mechanician on top of being a planetary scientist, who helped discover this trajectory by guiding his mission design team as an expert himself in how to find this double header that could go to so many objects. So we're going to go from never having been to any to having a collection of them to compare. And I don't know anything comparable in the study. For example, asteroids in the main belt, Galileo flew by the first one, and the New Millennium, or maybe another mission, flew by the second or third, and now we've got, a half dozen. We've flown by a few near-Earth objects as well. We've been by one Kuiper Belt object with New Horizons, but never before have we sort of overnight gone from having been to none to a whole bunch in just a short period of time. That's what Lucy will do, and it launches this October.
Wow, so coming up right away. And when I think of the apogee of any orbit or any mechanical pattern, for example, on the Virgin flight, your vertical velocity at apogee will be 0, because you literally go up there and coast to a stop and then fall back down, and your 0G exists once the engine's cut off all the way up and then all the way down. But the point I'm trying to make here is that your velocity is close to 0 at the top. what I see here with Lucy is that it's going to go up into that Trojan belt on one side, sort of fall back down closer to the sun and Earth to make another loop around, and then lob itself back out to the other. And so it's presumably when it's in those groupings of Trojans, I have to presume its velocity is nothing like New Horizons. It's actually moving quite a bit slower, which also might give you more hang time with your cameras and or make you feel more comfortable at getting closer than you might have if it was moving faster.
I see why you would say that, but it's not correct. And it's because the diagram is misleading in one respect. So that diagram isn't a diagram of the orbits in actual space. It's a diagram in a very particular coordinate frame that orbital mechanicians like, called a rotating coordinate frame. Okay, so Jupiter is stationary in this frame, and the Trojans that actually are orbiting the sun only are orbiting in these little clouds in this rotating reference frame that you see them in. And while Lucy will go from one side of Jupiter down into the inner solar system and back out to the other side, it doesn't come to zero and have long hang times like you suggest. It's actually traveling at many thousands of miles an hour, sometimes tens of thousands of miles an hour.
But even relative to those Trojans.
Right, the flyby speeds are maybe not as fast as New Horizons because it's a very fast spacecraft, but like a third to a half as fast. So still, faster than a speeding bullet.
Right, and so you obviously still want to.
About this trajectory is that after Lucy finishes with the second Trojan cloud, it falls back down to the sun and goes back to the first cloud again. So if the spacecraft's in good health and NASA decides to fund it, then we can do an extended mission and still more Trojans way out in the mid to late 2030s. So this might just be the mission. It's the gift that keeps on giving.
Excellent. Well, I want to move on to a scientific paper that you actually sent to me that invoked an interesting email conversation back and forth, which was I'm going to get the acronym wrong for IWOW. Can you tell me what that means?
IWOW.
Which stands for?
Interior Water Ocean Worlds. Interior
Water Ocean Worlds. There you go. And so that paper was noting that. And pardon my simplification, correct it if I misrepresented it in any way, that planetary bodies with interior oceans might actually be better for nesting or growing life, in that with fewer catastrophic events that seem to happen here on our heavily exposed Earth, that life might be able to not only just get a hold, but remain relatively undisturbed and therefore continue its path of evolution with more stability. Right. And as first of all, did I represent that correctly?
Yeah, it did. Can I elaborate a little bit?
Please, please.
So, at the beginning of the space age, before we had real space flight, just the earliest space flight, we couldn't really travel to the planets. Astronomers would look out with telescopes, and every world they saw was unlike the Earth. It looked like Earth was the only world in our solar system with an ocean. Because they didn't see any oceans, they made this conclusion that there are no oceans out there. The Earth is very special. And then went through this elaborate exercise of modeling to figure out this thing called a habitable zone, where you have this Goldilocks temperature situation. It's not too cold to freeze, and it's not too warm to evaporate the ocean. It's just right. And that led a lot of people to believe that habitable environments must be very rare because you have to be in a very special place. And then all the while, the geoscientists were discovering all these hazards, like catastrophic asteroid impacts that killed the dinosaurs and fried most life on Earth in some of these really bad events, and supernova that would go off and bathe the Earth in radiation, and titanic events that would occur if you had an Earth without a magnetic field to protect us from radiation. The list is long, and it just kept looking less and less likely that there were a lot of habitable abodes. Now, through spacecraft missions, we've discovered that there are lots of oceans in our solar system. Lots of them, like at Europa and Enceladus and Titan and Pluto and Triton, and the list goes on. And the astronomers were wrong. It's not that the Earth has the only ocean. The Earth is the weirdo because it wears its ocean on the outside. All the others have interior water oceans beneath a thick roof over the ocean of ice or ice and rock. And so those oceans that are deep down and which are nearly ubiquitous in the outer solar system among large worlds are protected from radiation, from impacts, from many other kind of lethal phenomena. In fact, they don't even care if they're close to their star. There are ocean worlds like Pluto in the Kuiper Belt where the liquid water, is at reasonable temperatures. It could support life in principle. So what this paper is about is taking that yet a step further. And I'll be talking about it at the Lunar and Planetary Science Conference next month. Um, and, and just thinking about some of the implications, not just for stability that you just mentioned, but also the really profound implications that if civilizations, well, this is wild thinking, but if civilizations were to develop in any of these ocean worlds, they might never know there's a universe beyond because they can't see the sky. They don't know there is a sky. And so maybe this is why we're not hearing from everybody. They're all in interior water ocean worlds. And they're perfectly happy where they are. And we don't see any leakage of electromagnetic radiation because of this big, thick shield of ice and rock. And they don't know we exist or there's a universe to explore. And Lord forbid, if they ever made it up to the surface, somehow they figured out, we'll just go see what happens when we tunnel.
When we drill up.
We drill up and we get to the surface. Okay, maybe they're really smart because they have a civilization and they somehow figure out those things are stars, but because they're big and buoyant creatures like whales or even porpoises that require a lot of water, they're so disadvantaged for spaceflight that if they could ever invent rocketry, you'd have to bring so much water, it would almost be impractical. Just the mass that you have to launch. Mitigate.
Better be a small planetary body.
Yeah. So anyway, it's a wild and speculative paper about astrobiology and these IWOWs, or interior water ocean worlds.
Well, not only do I find that really fascinating, but that also plays into, I've got a number of questions queued up from folks listening too on your personal thoughts on life beyond Earth. And I would like to just frame that in the probabilities. I mean, clearly you're thinking about life as it might exist beyond the Earth. How do you think of that, probabilistically from within our solar system, or how do you think of that probabilistically for in the rest of the visible or actual universe or beyond?
Well, I guess I have to say first that I hope that the biologists really get life extension down, because otherwise I probably won't live to see how this story turns out. But my bet is that when the story of the exploration of our solar system is done, that we will either find extant life or other abodes where life flourished for some period of time. And whether they're nearby, like Venus and Mars, or much further away in these interior water ocean worlds, what we're finding today is the number of potential environments is proliferating. And it's going to take a long time, even with an explosion in 21st century spaceflight, to really do the reconnaissance to understand where life formed in our solar system and for how long. And I would put my bets on a story in which it turns out in the end that at least for simple life forms, that our planet wasn't the only one to get the right mix over time in our solar system. Across the big universe, I think all bets are off. I mean, it's such a big universe, and we're finding so many planets around stars, and even planets between stars, which could support interior water oceans, because of the physics of how the geophysics works and the warm temperatures you expect in the interior if there's water ice that can liquefy, that it would be shocking, wouldn't it, if among the quadrillions of planets, we were the only ones to be so lucky as to be a habitable abode that's actually inhabited, and that eventually created creatures who were sentient and who could look up at the sky and want to go and explore the universe out of which our planet was born. It's really a profound thought to me that among all the species that have ever lived on Earth, that only Homo sapiens have had this realization that there's a universe out there. and even more so that we should go explore it. Pretty audacious.
I agree. I'm clearly on the side that, especially in the larger universe around us, it would be shockingly improbable if life isn't bountiful, though potentially very, very far away. Which brings me to something that interestingly no one on we have a very educated following this evening, because no one has actually pointed out the next question that I have in my queue that starts really with a kind of a personal story, which is when my father was on Skylab. He right after they launched, so he was still he hadn't actually docked with Skylab. Maybe I think he had docked with Skylab, but they had, with relatively soon after they had reached Skylab. He was looking out the window, and as you probably know very well, that at night when you want to go up and look and see the space station, you go right before sun up or right after sundown when you're in the dark, and yet the thing you're trying to see is lit up, right. And that's the easiest time to see it. And so right at one of these transitions, we in or out of sunrise or sunset, he looked behind the vehicle and saw what in his mind's eye was probably something like the bolt head or something from an explosive bolt that was used to separate parts and pieces as they reached orbit. And so it was basically some debris following them into orbit. And so then he took a photograph of that object, and it looked like this. And so hopefully people can see this little red squiggly. And that's because he was hand holding a long lensed camera for a long exposure photograph. So he believed he was just seeing one little tumbling, glinting object, but that's what the photograph ended up looking like. And at the end of taking that photograph, he got on the radio and said, "Hey, ground, but we have what seems to be an unidentified flying object behind us here on Skylab." And tragically, my dad, being the Spock-like communicator, he was using the word unidentified in the scientific term usage of unidentified. He in no way did it cross his mind that what he could be saying could be interpreted by people listening to this ground communication as that he was thinking of a UFO. However, that then made headlines all over the place, where my dad is, even on the internet, you go look at him, they say, yes, Owen Garriott claims he saw, UFOs, even in the time of Skylab. And so for my dad, this is like the bane of his existence, was this story. And my final personal piece of the story is I made a joke to my dad prior to my flight saying how funny I thought it would be to get on the ham radio on the International Space Station and click and go like, "Hey, this is Richard Garriott on board the International Space Station, and there it is behind me, a UFO." And as soon as I said that, my dad was literally livid with me to even have that thought cross my mind. And he said, "Richard, you will set science back by at least a decade if you make any kind of joke like that. You cannot joke with something this profoundly important." And so that was a long lead up to ask what I think I know your answer to, which is, what do you think about, we agree that there's life out there. What about life that from out there who might have visited the Earth?
Wow, that's a profound question. I have to say first that I sympathize, feel a little simpatico with your dad, because I once, shortly after the flyby of Pluto, gave a scientific lecture in Calgary, and I was referring to our discovery of a convecting glacier by saying that the glacier was alive, and I meant geologically alive. But the next morning, that's not what the headline said. And the next morning, my phone was ringing off the wall by executives at NASA headquarters, asking, "What are you talking about?" And of course, I was talking about Pluto being geologically alive. But boy, it got misreported. So I understand.
And that also just goes back to the importance of accurate scientific communication when you are in areas that can become so charged with profound meaning to the human condition.
Absolutely. I haven't seen anything that's convincing evidence that we've been visited. And you might think that it would be completely obvious. Um, that's certainly a school of thought behind that. If we had been visited, we would know it. But on the other hand, the ants in Manhattan are visited all the time, and they don't know it because they don't recognize Manhattan around them. So that's another school of thought. I would put myself as an extreme skeptic. I think it's a tall order, and there's no strong evidence. And so until I see evidence, I don't see any reason to believe that the Earth itself has been visited by others, other than perhaps planets in our solar system swapping a little biology through meteoroids. But that's not intelligent life.
Right.
Now, whether interstellar travel can be developed by civilizations, I think that is not unlikely. But there are so many locales, I said before, quadrillions of planets in the universe, that particularly if a lot of the advanced civilizations are down under in these water ocean worlds, they're not out there traveling because they don't develop space travel. So I need to see a lot more, and it's not obvious on our planet, or it would be very well known that we had been visited. So they're either stealthy or a long time ago or not at all.
And what do you think of, I at least have a lot of folks, friends and folks I know who have been avidly consuming, shall we say, the Harvard astronomer Avi Loeb's new book, Extraterrestrial, where he talks about the recent solar system visitor we had that came in and out of our solar system so quickly, and speculates as to what that might be. Any
By
thoughts
this
on that?
visitor, what you're referring to is something that was predicted in the 70s, 80s, and 90s, including papers that I wrote, which is that there are plenty of debris shards in interstellar space, asteroids and comets, planets too, but the little guys way outnumber the big guys. So we should eventually detect, and now we know that we have detected an asteroid or a comet, in fact, a couple of them, that have come through from interstellar space. And this is what Abby's writing about in this book. The first of those objects, called Oumuamua, which he makes a case for, and I haven't read the book, so I can't judge it, but he makes a case for it possibly being of alien intelligence, the creation of alien intelligence.
And how do you feel? I've got a bunch of questions from others queued up, and I want two more things for on my list before we open up to these other questions. How do you feel about humans settling relatively permanently, if not completely culturally, civilization-wise, on the moon and/or Mars?
Oh, we have to do it. We absolutely have to do it for economic reasons, and ultimately for survival reasons, and I also think for creativity, for the arts, for many intangible reasons. Just as we spread out of Africa across this planet, the planet's getting a little too small for us, in my view, and we have the technology to do so many more things that I think we have to go to settle places like the moon and Mars, but also much farther away in our solar system. And there are tremendous resources and tremendous scientific benefits to be had by this, and tremendous cultural and arts, and who knows, even potentially new governmental models. The same way that democracy was born by the Europeans coming to what they called the New World, the Americas, and eventually those cut off and far away civilizations, our civilization here in the United States, created this new model for governments. And I think that the next few centuries are going to be transformational for our species, partially as a result of colonizing the solar system.
And let's jump one more in kind of the linear queue of things I knew I wanted to talk about, and then I'll go to some questions that people have been queuing up, which is your new book. And so let me share an image of that. And so tell us about Chasing New Horizons. It's we know the general topic, New Horizons, but what more specifically?
Well, this is a book that I wrote with my friend and colleague, planetary scientist and author David Grinspoon. and which was published in 2018. And it's, I call it my 100 Lost Weekends, because David and I spent 2 years on the weekends writing and rewriting and honing the book. And it's been very well received, and we've given hundreds of public lectures on it. It's the whole story, soup to nuts, of how this amazing space mission came to be against all the odds, how we built it in record time, all the problems that we had, political and engineering. And it's really a book for the layman. I think people in the Explorers Club would love it, because it's really written as a story. And yes, there are a couple of chapters that are kind of under the hood nerd engineering to show you how you build a spacecraft like this that can travel at such speeds and across the solar system on its own, and how you plan in detail a one-shot flyby. But it's really the story of the people who did it, and how they overcame long odds through persistence and being ingenious and some luck, and carried off this epic mission to this place that I like to call, where the solar system saved the best for last, Pluto and its system of moons. And then in the end, the book is actually about a transformation that I had as the principal investigator, who always thought that there was great science and great reward for our careers in putting so much time into this over 2.5 decades, but who was bowled over by the people, children and adults alike, men and women in America and across the world, who by writing or by coming to see us would tell us how this inspired them or changed their lives in some way, how it turned their children around from slackers to wanting to be scientists, for example. Or one gentleman who came in tears saying that he was on the verge of committing suicide. And this gave him new faith in humanity. And it was just so humbling how many times we heard this change people's lives for the better. And it's something I never expected to get out of a scientific career, to be part of that kind of transformation of just regular people who saw something larger than life in what we were doing. And the book has some very personal stories about that. And that's how it ends, in fact.
Great.
So thanks for mentioning it.
And by the way, I agree. It's perfect for the club. So sometime actually, post-COVID, we'll have to, perhaps have an event at the club too, where we can talk about the book more and share it with members more directly. But I'm going to jump into some questions. People, these are going to go back and forth the things we've already covered. But since it looks like we still have a little bit of time, I think we're close to the end of our time frame. But I want to at least get a few more guest questions in, if I could. Shelley Henry asks, with all the missions and plans for scientific study that are done or up to this point in time, what are you thinking about post space flight? What is for you the great unachieved next project that you don't already have, in the plans or discussion?
Well, first, in case I gave the wrong impression, I hope to be involved in space flight for a long time still. And I don't see any reason why. I have some role models who are into their 80s and 90s, and so I won't be there for a long time. And so I'm not really thinking post-space flight very much, other than maybe to spend more time outdoors and with family and friends. But I'm not thinking about a post-space flight career. The universe is just too big and too interesting to walk away from.
Well, let me more explicitly ask the question, maybe, because they're saying, what is your next dream study? In other words, if you were to think of the pantheon of things happening within the solar system, within the reach of our probes or people, what do you think? We now have, New Horizons is seen as one of the great human endeavors. What do you think one of those next scientific great human endeavors is?
Well, speaking personally, I would like to leverage the suborbital space flight into orbital research missions for myself and my group using commercial vehicles. For example, to the ISS or commercial LEO stations that are going to be coming online in the next decade or so. But I think the really, really big transformation is for humankind to have a permanent presence on the moon and the first expeditions to Mars. That I think would be hugely transformational for society, not just for science, but more importantly for society. to see what human beings can do and what the potential is. I hope that in 3 centuries' time, people look back on this time. I truly believe it's an inflection point. I think people will look back on the 20 teens and 2020s and say, unlike that false dawn in the 50s and 60s, maybe the 70s, of spaceflight, when it was too hard, that by the 21st century, the early 21st century, it became really tractable. Thing that didn't take superpowers or even nations, but corporations can do. And so I hope that in 3 centuries' time, people look back on this time where we're living and say, boy, that was the time. That was when Star Trek began. That's when it all really got started.
I actually hope you're right. I think that's a good analysis. I like that a lot. Ron Franco would like to know, for your Virgin flight, you have to have been thinking about, if you haven't already planned, what personal items you plan to take along with you on that flight, symbolic or otherwise. Have you given that much thought yet? And can you elucidate what you're thinking?
Ron, that's one of those I could tell you, but then I'd have to kill you stories. I will say I haven't given it a lot of thought. Many people have made a lot of suggestions, and I think I'll focus on that next year. So it's probably disappointing, but I think I'll focus on it better when the flight is closed.
Brad France asks, he's saying he has a question about celestial observation. When you observe the night sky on Earth, you notice the shimmering of stars, but you do not notice the shimmering of planetary light. And so he's saying, why is it the stars and planets, when you look up at the night sky, why do they appear differently?
That's just a trick of the human eye. And in fact, if you take binoculars, high-powered binoculars, or a decent amateur telescope, and look at the planets, you will see that same shimmering. You can even see it looking at the moon. And that's just the turbulence in our atmosphere. That for whatever biomechanical reason is easier for your eye to detect in a point source than in a more distended object. But they're actually suffering the same thing, and that's what limits, or it did until we invented more modern technology, limited our ability of Earth-based telescopes to have really high resolution.
That makes me think of something that I get asked all the time, which was, how did the stars look when you were on board the International Space Station? And
how do the stars look when you're on board the ISS?
Sorry?
What's the answer? How do the stars look?
Oh, yeah. Well, the answer is unremarkable, and or almost never seen, in fact. And it's worth pointing out that when you're in the space station, you're only 250 miles up, so you are not relevantly closer to any object outside of the Earth than you were when you're sitting on the Earth. The only thing you don't have is the atmospheric shimmer that created the twinkling of some of the things, the shimmer that you see on some objects that you look at by eye or with binoculars, as you were saying. And the space station has something like 120, it's plus or minus 10 windows on it, lots of windows all over it. The vast majority of those windows aim straight down at the Earth, because that is by far the most profound thing to look at, is the Earth. And the rest of them aim, port and starboard, and off the bow and the stern in the direction of travel of the space station. So those are plentiful also. And at least at the time of my flying, there were precisely 0 windows that aimed up into space. Exactly 0. And the reason why was because the view upward is so unremarkably different. And what's interesting is I have some friends that flew on the shuttle that actually describe something differently. And the difference between flying on the shuttle and the space station is the space station never goes completely dark. There are lights on it, like you might think of on the outside of an airplane, to where there's always a little backscatter of light in your eye from light scattering off parts and pieces of the space station. And I have heard tales of people who go up on the shuttle saying they would all gather in the cockpit and literally power down the entire vehicle. So there's no instruments on at all, and there's clearly no lights on the outside. And they actually would say with that level of true darkness, and you get really dark adapted, that they would really feel, in the cosmos in a way that they found very meaningful. But I actually would never experience that from the ISS. And sadly for you, you're going to be doing a daytime flight, I presume, because for your experiment. And so you also won't get that particular experience on this flight. Maybe next time. Let's see here. Oh, so Laura Berry asks, do we think there will be tourist space flights in the coming decades? I think we can both take a crack at that one.
Well, there were tourist space flights in the previous 2 decades, and Richard was on board one of them. And of course, Blue Origin and Virgin Galactic are very far along. They'll probably, barring something we don't expect, they'll probably both fly their first paying tourists this year. And then hopefully that will scale as they build more vehicles and more bases to launch out of. And there should be a lot of that. And I think orbital tourism, we're already seeing it take off in a way that's really accelerating compared to the Soyuz days, with missions like Ax-1 from Axiom, with the purported film with Tom Cruise, with the new Inspiration 4 mission that had a Super Bowl commercial last night and is going to select at least part of its crew by lottery. And this is only the first few examples of what will probably proliferate into a cottage industry of orbital space tourism alongside a much larger 2020s industry of suborbital space tourism at lower costs. And then eventually, I think within most of our lifetimes, we'll see lunar space tourism and eventually Mars space tourism. And why shouldn't it be that way? Just as people who wanted to come to up across the oceans to other continents could do that too, if they had the resources and the will to make it happen.
I'm a couple of great questions here being forwarded to me by Kevin at the club. I'm sorry, I don't know who they're necessarily coming from, so apologies if I don't credit the person. But interesting question. If life can possibly be found miles underneath the ice and rock on one of your ocean worlds, inner water ocean worlds, they're noting that how difficult it is to explore our oceans here on Earth. Like actually in 2 weeks, I'm going down with Victor Vescovo down to the Marianas Trench, and that capability, requires a 10-ton vehicle, a gigantic support ship, and has only existed after 60 years after Don Walsh and Jacques Piccard went down there with Trieste. And still only 15 people, after we go, will have ever been to that depth. So how in the world are we going to do that, on Europa? How are we going to find your life that's buried under that ice?
Well, we have some tantalizing clues. An example is this wonderful water ocean world called Enceladus, which is an icy satellite of Saturn. And Cassini discovered geysers spewing tens and actually over 100 kilometers into space. And then Cassini actually targeted flybys through the plumes with a mass spectrometer and was able to detect salt in the water, so it's a salt water ocean, and detected organic molecules. Just tremendous hints that there could be biology down there. But the technology to actually go down through those fissures into the ice on these very faraway places is a little beyond us. But I don't think it's any further beyond us than what we do routinely, like fly to Pluto, compared to the 1950s and 60s, when all they could do is loft a big ball called Sputnik. They couldn't do much of anything. So I think by much later in this century, those kinds of missions are going to be tractable, and the technology to put them on is already being developed, but will be at a sufficient readiness level to see in our children and grandchildren's time. I look forward to it.
Great. I have one more general public question and one more question from the club staff here for you.
Go for it.
Which is, if you were the NASA director or emperor of the universe and could kind of set the agenda for our national or global space programs, what do you think the priorities should be? Where should NASA or the world focus its efforts? Do you think is the moon the most interesting target? Is Mars the most interesting target? Should we really be, reaching out as far as fast as we can? Should this be done purely by government funding? Should it be a competition? Should it be privately funded? That sort of thing.
I don't think there's a single answer to that question. I think we should be doing all of these things, and we can. And now that so many companies are capable of mounting spaceflight, even to the moon, and now to the closer planets, as well as so many more countries, I think we're going to see a tremendous acceleration as we proliferate the number of space efforts that are taking place. I think the most important single development of our time is the development of private spaceflight, which allows us to leverage by being able to apply the techniques that formerly took superpowers down to the scale of small companies with only dozens of employees. And it's going to be transformational. And one of the most important things NASA and other national space efforts across the globe can do is to foster that leverage in the same way that we have gotten a lot less done here on Earth if only navies and air forces ruled the oceans and the air as opposed to big commercial fleets in both cases. But we have to also do all that science, and we have to go looking for life, and we have to start to reap the economic benefits of space in ways beyond just communications and remote sensing. And we have to explore farther and farther because all of those things are going to be important to creating that Star Trek future, which is so boundless and unlimited for our descendants.
Well, excellent. And Ann Passer, who obviously helped put this event together, but is also head of our lectures and programs, for the final thing, wanted me to try to put the squeeze on you, use whatever leverage I can to get you to commit that, as an Explorers Club member, as a Lowell Thomas awardee, when you do take your flight, we're hoping that you keep us in mind here and give us as close to real-time access as we can to that so that we can not only follow along, but help bring your fellow explorers along with you on your upcoming mission.
And that's a great idea. We should talk to Virgin Galactic to see what's possible with the bandwidth they have for real-time communications that are on board. And maybe we should even have a conversation about an Explorers Club flag.
Perfect. Well, first of all, personally, Alan, thank you. What a wonderful discussion. I learned a lot personally, even beyond what I had already learned through our email exchanges ahead of time and our many conversations down through the years. So thank you very much. And I know, even though we can't see the audience, I know Anne and Kevin are live on our two main feeds, hearing people's responses. Whoops, and I'm even getting something pop up here. Let's just make sure that. Okay, got it. Okay, she says, let's do it. Ann says, let's do it. So,
sounds good.
But also let me thank to all of you in attendance, both those of you appearing live, and we have found that these lecture series has now been getting picked up a lot. This one was going to be one of our most popular, both for live attendance as well as after attendance as well. Thank you, Ann Passer, for helping to organize the event. Thank you, Kevin Murphy, for helping produce the event. And if you'll pardon me, Alan, before we both sign out or sign off the evening, I have a couple of club announcements I would like to kind of throw in here, which specifically are next Monday, there's no lecture as it's President's Day. So join us this Thursday, February 11th at 7 p.m., where the Explorers Club will present Women Explorers in History to celebrate the International Day of Women and Girls in Science. This event launches a year-long series of exciting programs, media, and educational outreach to honor and showcase the Explorers Club members and other women in the field. It's going to be hosted by Milbury Polk and our own Lacey Flint. Chapter Connect will resume a week from Thursday on the 18th of February with Tim Radke, and as he introduces you to his Southern Californian chapter at 6 p.m. Eastern. And on Monday, February 22nd at 7 p.m., we have our ESRI, from a program about from data to understanding and back again, with Keith Van Graffeland, pardon my pronunciation, and John Nelson, hosted by Santiago Pardo Sanchez. So anyway, those are our club announcements as well. Again, Alan, thank you so much for being here with us this evening. I'm very excited about your upcoming flight. I really hope we get to follow closely and take the rest of us explorers and the rest of the world along with you on your Virgin flight.
Thank you, Richard. Thanks to you and Kevin, and especially Anne and Richard Reese for setting this up, for inviting me, and for making the interview so enjoyable. Thanks.
Oh, great. Well, have a great evening, everybody. Everybody stay safe in this complex COVID time. It's been great that we've all been able to get together like this, which in a weird way has allowed us to embrace a wider circle of us and get together in this socially distant way. So thanks, everybody. Good night. Be safe.
Be safe. Good night.